All right. Hello. Can you hear me now? I guess so. Hello there. Hi. Sorry for the technical issue at the start. My name is Andrei Viktorov, and I welcome you to this third livestream session where we are going to create the first-person shooter demo. I will show you the basics for today's livestream session. We are gonna learn how to do a simple first-person setup, how to mix first-person animations, how to create effects such as muzzle flash. Hello Daniil, hello Vladosko, hello Stalfed, hello Kapikawara, hello Richard, hello Lev, hello Terraria, hello Isen, Patricia, hello. Alright, so let me switch back to my main screen, and from there we'll start building our first-person shooter. Actually, two more things I want to mention. The first one is that it will be a live stream series, so there will be at least one more stream regarding this theme, building first-person shooter demo. And the second thing is that we will have a Q&A section at the end of this live stream session. So if you have any question, feel free to ask during the Q&A section. And also, if you have a question, you can just ask and type it in the chat, and I'll do my best to answer it. All right, so let's get started. By the way, can you hear me? Can you see me? Is everything all right? Should be all right. All right, let me switch back to the main screen. Okay, so the first thing that we need to do is we need to create a new project. All right, so let's create a new project. I will call it livestream session_3. Here the location is, this location is okay. The SDK, actually, last two streams were on the previous SDK 2.12, and this live stream will be on the latest SDK 2.13. Finally, content what we deserve. Yeah. So the engine binary is still we're gonna use development version. We won't use any template, and we will use C#, and of course we will use float precision. From Artie, hello. All right. Hello Andre, hello Vincent. Hello Alexander. All right, let's wait while it will create a new project for us. Another thing that we will need to use is C# samples. I will show it to you once I will create this project. Hello, Last Light. Good to see you. Yeah, a long time no see. All right, so let's open and see what do we have in here. From my messing around with UNIGINE, I love what I have figured out so far. Good to know, yeah. All right, so here is our demo content. If we run this demo as it is, it will already have a first-person controller in it, and yeah, basically we can just use it right away. Let me show you. Legendary. Right, so yeah, here we have first-person controller. Okay, stream is done. Good to see you. Bye. No, it's not. It's not how we will going to build this demo. All right, so the first thing is that in this live stream session, I won't go into details on how to create like your own first-person controller. This is not the topic of this live stream. That said, we are going to use existing first-person controller. If you go to inside this node reference, you will see that there is already first-person controller here, and that's the component we are going to use. It's located here in C# template, first-person controller components, first-person controller. If you have a look at it, it will contain a lot of code, but don't worry about it. We don't have to like understand what's happening inside right now. For this live stream, we just going to use this UNIGINE or Unreal Engine. This is UNIGINE. Just for interest, can see. Oh, okay. Sorry. Let me put it like so. Yeah, I always forgot that chat is taking some part of my screen. All right, so in this first-person controller, we can tweak a lot of stuff. Probably we will keep it as it is now. We don't need to change anything right now. All we need to do is to understand what's what. Like I will give you like a basic description of what you can do with this. First of all, this controller is tied with input. It can handle both keyboard, mouse, and gamepad. You can also have your own physical body. If you have like some sort of a complex stuff, then you can use your own existing body. If you click this, then yeah, it will allow you to create a camera attached to the body, and yeah. Basically, it's these parameters are like most common across multiple engines like capsule radius and height and many others. But we are mostly interested in the movement parameters because that's why we need to why we want to use this component in the first place. So we want to tweak like how we walk, how we run, how we jump, and stuff like that. And here we have a lot of things to tweak, and as I already said, we'll keep it as it is. But if you want to play around with it, feel free to tweak these parameters and see what will happen. All right, so the first thing that we are going to do is we are going to import the content that was already made before the live stream session. It contains the hand stuff and some content for the shooter. All right, let me just put it like here. Is UNIGINE easy to learn? If you're familiar with other engines, then yes. If you're new to UNIGINE, I think it is reasonably easy to learn. All right, so I imported a pre-existing content, and some part of it were taken from the third-person shooter demo, which you can find in the samples section here. Samples, demos, C# third-person platformer. And I will show you what we actually took from it. We took a bolt, not FBX. I need a node. Is it okay? Should be imported. Okay. What about particle effects? Okay. Looks like I imported it in a wrong way. Let me just redo this. All right. Basically, we took like explosions, bullets, and visual effects from this third person platformer demo, and as a new content, we took this. This will be our main topic for today: how to do first-person setup with hands and pistol. And I guess yes, for some reason, all the materials and texture were missing. All right, let me redo this. All right, let's create a folder. Let's call it shooter. Robot with human arms, nice. And let me just import it again. And see. All right, let's try. No. Hi, there are lots of FPS tutorial and games, but will any RTS tutorial come up soon, like top-down camera like CNC generals? I think, yeah. Like I can give you any ETA about it, but at least in previous versions of SDK there was RTS sample as well. So if you really want to dig, you can have a look at the previous versions. But I would say that if you will leave the feedback that you need this, and if there are like a lot of you guys asking about like, hey, we want this topic to be covered, then yeah, of course. All right, for some reason I can't. Yes, a lot of textures are missing. Like, I don't care about the sounds right now, but I do care about textures. All right, let's not work with that. Let's at least have hands and pistol set up, and then we will figure out the rest. Yeah, and robots are also missing materials. Never mind, we'll work without that. All right, so the first thing I want you to know and understand is the first person setup. So for this we have two main objects. The first object is the hands itself. It's basically the skin and mesh, right? Let me put it right inside to the first person controller. Okay. Yeah, here we go. RTS tools, where can we get it now? It works on current Unigine version. There are no RTS tools. The thing I wanted to say is if there are a lot of you guys asking for a specific topic, that we will listen to you, and yeah, of course, it's possible to cover that. All right, so let me show you how this thing works. So I attached the hands to the first person controller. Let's see how it looks. Wouldn't be a live stream without tech issues, right? You're right. And it seems, oh wow, yeah, my hands are in the wrong position. All right. Slidey hands, yeah. Okay. So here we wanna change something. We can do it like we can go two ways. The first way is we can tweak these parameters, like what would be the camera position offset, and then we can apply the same offset for the hands, like so. And then I guess we will have our hands, right? Yeah, no animations and a little too high, but yeah, we have our hands. And then let's actually do some animations. Yeah, zombie hands. Yeah, right. Okay. So in order to have a look at the animations, before that, let's actually create a camera, because that would be much easier to test. So here in the first person controller, we will switch create mode to use external. And here we can have a camera. Let's create a camera. We are going to use, what's it called? Player dummy. It should be create, where it is? Camera dummy. And we'll put it inside. Yeah. Come on. Yeah, here we go. All right. And seems like we need to add filter in this tooltip. Let's move it back to here, and let's rotate it 90 degrees. All right. So by doing this, we can create a camera setup like this, and we can have a look at it directly in the editor. This is very useful, especially when we need to create our first person setup. All right, so here we have a first person controller. Let's drop a camera here. And see. No camera. Yeah, because we haven't checked the main player here. All right, so here we have our camera. Looks better, but we can't see our hands. That is what we're gonna fix right now. Okay. So we will attach our hands to the first person controller, and then actually it is better to have a setup which is relative to the camera, because that way you don't need to move your hands. But actually let's put some animations and see if we need to change anything at all. In order to test the animation, we can have a look at this section where it says preview animation, and then we can select the animation we want to use. For this particular demo, I have a few animations for our hands. It assumes that we are going to handle some sort of a pistol, right? So let's have a look and go inside FBX, and here we can see that it contains animation. And then let's play. Okay. Let's see if we can see our hands. All right. But we still can't see our hands. Should be able to see them. Maybe clipping camera. Not really. It's basically a misplaced transformation. We should be doing like so, or actually better to do it the other way. We can do it like so. Let's have another viewport with the first-person camera. And then we can have... Yeah, this looks misplaced actually. Should be placed more better. Please adjust near clip lane. Yeah, of course, I will do that. But that won't help like really much, but okay. All right, let's move our hands back and show. See, still not, we can't have a look at them. Let's actually see it in action and oh wow. Okay. And yeah. Zombie head. Yes, yes, yes. Right. Let me put this somewhere. Let's put it here. Okay. Let's put it back to here. Like so. All right. We don't need to set like very small values for the near plane because that won't help us a lot. What I want to do is to play this animation and see how it will look in the first person. Yeah, this looks like it's mispositioned. All right, let's get back to this a little bit later. The second thing I want to show you is how to actually attach a weapon to the hand. For this purpose, we have an FBX model with with a pistol, and we are going to attach it to our hands. So how can we do so? There is a specific node that's called mesh skinned bone. Actually, it was renamed. If you use like previous versions of the engine, it was called World's Transform Bone node, and so now it was renamed and placed inside the mesh section here, so don't get confused by that. So we are going to use this node. Is the game going to be free? Because it might be one of the first people to play. It's not actually a game, it's just a like a demo content on how to use the you know, how to create a game. Okay, so here in this section, if we place the world transform bone inside our mesh skin, then we will have the opportunity to select the bone here. And what we need is we are going to select joint hold. And if we will have a look at the bones here, we can enable bones here in the bones section. We can click visualize, and then we can select this. So this is the pivot position for our weapons. Well, I just got here and I wanted to know. I think we will put this content for the live stream session publicly available, but don't expect it to be a game within 2 hours. Okay, so here we select joint hold, and we can already see that it's changing its transformation here. And what else do we need to do is to put the pistol inside as a child. And so we have a pistol attached. This should be shortest game for relatively normal price, 16 bucks. Yeah. Alright, so actually it's not that bad. Yeah. All right. So we have a hand, we have a pistol attached to the hand, and yeah. That's how you basically do like a first-person setup. One thing I wanted to mention is that the as you noticed, camera settings are very important. Like the near clipping plane is important. You can play with different field of view. Like you can have like 90. Actually, let me just try to play it with it here. Something like that. Yeah, that. Maybe not that much, 75 maybe. Now it's better than Cyberpunk. Better is Call of Duty already. Wow, that's too high. Okay. Let's keep it as 75, I guess. Should look better. And by the way, it's not that easy to do a proper first-person setup, because typically you will have 2 cameras. The first one will render the environment and basically any other object except hands and weapons. And there will be a specific camera for the hands and weapons only, which might have or might not have different field of view settings. But I am satisfied with that field of view. Okay, good. Let's go to the next section. Now we are going to write some code. And I'm gonna show you how to mix that animations for the first-person view. So first of all, let me show you what do we have here. We have a few animations. First of all, you already saw idle animation, and let me show you another, like maybe shoot animation. And we have another animations like walk forward. Let's actually play it with with this animation. Right, so yeah, now it feels much better if I walk forward and the animation matches my walk speed. Feels nice. But if I stop, this started to feel very odd. So we're going to write a simple component which will mix those animations for us, right? All right, let's stop this. Let me create another folder here for components. And now here goes the code. We will create another C# component. Let's call it hand animation controller. Okay, so here we have our component code. Can you see the code? Do I need to zoom it in, or is it? Can you clearly read this code? Okay, in HD, yes, I can. Okay, let me put it like so. Maybe like so. Okay. So first thing that we are gonna need is to get our object skinned mesh. Object mesh skinned dash skinned. It will be our private field because we are going to assign this component to the mesh skinned. Let me actually. Oh, never mind. Okay, I will leave it here. Okay, so what we want as we are going to use this node and assign a component to this node. Let's do it right now. Hand animation controller. All right, so now this mesh skin has the hand animation controller component, and in its section we can grab this node and we can cast it to object mesh skin like so. Node as object mesh skinned. UNIGINE is world best game engine. Yeah. Yes. Okay, so what can we do with it? First of all, let's add another parameters for animations. And for animations, we are going to use to refer to a specific animation, we are going to use string type. Public string. Let's call it idle animation, and we want to be able to set specific type of files to it, so we are going to add an additional attribute to it. We'll call it parameter file, and here in the filter we are going to use anim. So let me show you how it looks. So here we can select an anime file, and we can either go to the hand animation, go inside FBX and I lost it, and drag it like so, or we can do the same thing here. We can just click to this folder icon and go to our content, go inside FBX and select the animation. Say something in Russian. Unfortunately, this stream is in English because the live stream audience is worldwide basically, so sorry, no Russian. But I can repeat the the topic for today's live stream session. So the topic is how to create a basic first-person setup, how to mix animations, how to create effects such as heat, bullet heat or muzzle flash, and how to actually test if we hit something. That would be it for today's live stream session. All right, so now we can refer to the animation, and let me just duplicate those. So let's do it like so. Move backward, move right, move left, and shoot. Okay. So let me first assign all the animations. Walk forward, walk backward, move right, move left. Please tell me if I can make my own animation in this engine. If by animation you mean like bone animation, then the answer is it's typical. Like the typical asset pipeline is to create skeletal animations as well as 3D models outside game engines and then import them. Okay, and the last one, should. Okay, so if I will disable this preview animation here, yeah, I don't have. Yeah, I'll just delete it. And if I stop, so how can I play this in the code? So see, no animations, zombie hands again. So how can I do this? So the quickest way is to just do like so, set animation, first layer, which have index 0, and then the animation, and then just hit play. Maybe you can use Blender to create animation as FBX to import into the engine. Right. This is the preferred asset pipeline. Like it's the industry standard. Like not the Blender, but the pipeline itself. So see, now we play the same animation in the code. But let's do something better. How can we change which animation to play? Of course, we can go like very simple way. We can go like get data from the first-person controller about what's our current velocity, and then select the animation. But it will look very bad, to be honest. Instead, we are going to mix them. But first, let me show you this bad version, and then we will improve it. We need another parameter, first person controller. Let's call it FPS controller. And we can assign this controller to our component here, like so. So the engine knows that this node has component, like has first-person component, and therefore we can assign it to this field. So that way we don't need to look for a specific component here and do any other boilerplate code. We just use this controller right away. So what's interesting in this control? What can we actually work with, and how can we understand what are the available parameters? So see here, you can notice that there are a few regions, and for example, in the editor parameters, they are all private, so we can't actually change or read them. So let's just fold this out, and then we have a player properties, which are public and read-only. And this actually is what we need. Most of the time we will need this horizontal velocity. That's how we understand what the current velocity is. Okay, so let's give it a try. Let's give it a try in a very simple manner. FPS controller, horizontal velocity. Let's just check if our character is moving at all. Horizontal velocity is, and we can do so by checking if horizontal velocity is close to 0. That means that our character is not moving. So if horizontal velocity is not close to 0, then we think that this character is moving, and therefore we can play different animations. So let's just test this. Mesh skins, set animation 0, and here is moving. Move forward animation, and or else it will be an idle animation. Let's see if it worked that way. Looks like it's working, but the transitions between animations are very clunky. So how can we fix that? In order to fix this, we need to play two animations simultaneously and then blend between each other. And we can do so by having multiple layers, and then we'll be able to assign a different weights to these layers, and therefore we can blend the animations. Let me show you. So we can set num layers to 2, and then set animations here to, is there be a legs? No. And here move forward. Okay. This is the point where I would simply start to cry to implement this. It is actually pretty much simple. So let's say that we have, in order to blend these animations together, we need to store additional variable, which will tell us what are the current idle walk mix. Let's call it like so. So if this is 0 means idle, 1 means walk. And hey Andrew, what's about future plans for mobile development on UNIGINE? I think better to ask dev team about this. By the way, do you have an example of NPR shaders in UNIGINE? What NPR is? Maybe you mean PBR? Non-photorealistic, I see. I think, yeah, if you have a look at the documentation, they actually teach you how to build the material from the ground up, and you can use any BRDF you want. But that's like very... it's not hard, but you have to do a lot of stuff in order to do like a full feature set for such material. Okay, so what are we going to do? So here we can define our target idle walk mix, which is basically if we are moving, that we need to set it to 1, otherwise to 0. Yeah, why don't you make a course on Udemy about UNIGINE? I don't know. Okay. So, another thing that we need to do is to define 2 weights for our layers. Current idle weight or just idle weight. And here we will basically do it like so. Current idle walk mix and walk weight current. We basically do a simple crossfade animation, right? So if this is goes from 1 to 0, this goes from 0 to 1 and vice versa. Then we will do set layer weight 0 and idle weight, set layer weight 1, walk weight. Okay. But as you might notice, we still haven't changed anything about this variable. So we have a target idle walk mix and we have a current idle walk mix. All we need to do is to do some sort of a processing here, like some func, which will take target idle walk mix as an argument and also current walk mix as an argument. And it will do some calculations and then return a new value. And we are going to do this very simple trick. We are going to use simple lerp animation with the specific values here. And here we can define some sort of, let's call it idle walk mix damping. And also let's put it here as a parameter. Let's set it to 5, for example. We need to multiply it by the IFPS here, or if you might familiar with the delta time, then it basically it's delta time basically. So that way we will make this code frame rate independent, but it will still do what we need. And what exactly will it do? Let's think that we do this instead. So on the first frame, we are going to be halfway between the current value and the target value. On the second, let's assume that this parameter is not changing at all. On the second frame, we will be half step between, like, let me show it, the current 0, target 1. So after calculation, we will be 0.5. So we basically are going to be exponentially moving towards the target value. And so it's 1 plus. Like so. Isn't there a crossfade function to blend the animations? Out of the box, you can only manipulate layer weights directly. There will be an additional tool set in the upcoming versions, but for now, I'm gonna show you how to do it without any tool set. Like, if you wake up in a desert and you have to write your own first-person shooter without any tool set, that's how you're gonna do it, right? So basically, all other tool sets like blend trees and other tools, they are do the same calculations here. Okay, so that's why it is important to understand like the underlying layer. Okay, so basically this is some sort of a smoothing, right? Right, the more you write by yourself, the more control you have. That's true, but if you have a complex setup, then this mixing code might become very messy, and like having a dedicated blend tree and a specific tool is a nice to have. Okay, so here we have a current idle walk mix. Let's actually do it like so. So first of all, we calculate the weights, we set it to our layers, and then we calculate new value. Let's see how it looks. Okay, something's wrong. Let's have a look at what we did wrong. Under block dumping, okay. Set frame. This might work. I wanted to avoid that in the first place because basically, oh yeah, you're right. So the thing is that once we call play, it will only play the first layer, which has the index 0. So we need to do it manually, and by doing manually, I mean like we need to store another variable, which is current frame, and then we will just increase it. And here we need to multiply it by the animation speed. But actually we want to control it ourselves, so let's call it move animation speed. So we need to add another parameter here, which game designers or artists can tweak, and we go with 30 frames per second. Okay, and once we calculated weights, we can set frames for the 0 layer, like current frame, and for the next layer. That means that we will keep these two animations in sync by setting the same frame. This is important to understand because when you have like an idle and a walking animation, they are usually in sync with each other, so you have to play them synchronously. Okay. Still not what I wanted to see. Let's keep it the same way as it is here. So it is layer frame. That's correct. Probably I need to enable layers. So I believe there should be set layer. Yeah. So yeah, let's actually enable them once. Set player enabled. This is enabled by default, but we will be explicit about it. Okay, so we enable both layers. We set up layer weights and we set up frames. That's all we need to do in order to blend them. Yeah, thanks for the suggestions, we are devs. Okay. And yeah, I actually doing it wrong. Okay. Oh yeah, of course, I need to switch this. So, oh no, not like so. If is moving, then target idle walk mix should be 1. That's correct. Yeah, like so. Okay, so we have an idle animation, and then we can have a smooth transitions between walking animations. So basically, as you can see, it's the same approach, but instead of just switching animations, we are blending them together. And we need to do the same actually for left and right. And here we need to do like a little bit, like we need to add more complexity, because now we need to know which direction we are moving. We don't only, we can't just rely on this. Luckily, we have a horizontal velocity here. Okay. Let's do it like so. So, what an amazing revolver, by the way. Yeah. Let's add more animations. So we will blend 5 layers. Move backward, move right, move left. Let's do it like so. What hardware are you using right now? It's i7 9th gen and 1080 Ti, 32 gigs RAM. Let's simplify it a little bit. Okay. So this stream will be recorded and stored on the channel. Yes, of course. I have to do something else. I cannot watch anymore. Don't worry about it. The stream will be on the channel. Russian, yes. Okay, so if we have a look at the FPS controller here. Have fun, everyone, and take care. Thanks. Here in the first-person controller, if we go to the code and have a look at the what else do we have? We have 2 vectors here. It's a slope axis X and slope axis Y. And that might sound confusing, but it is actually what we need. This basically is the forward axis for us, and this is the right axis for us. But when we will hit like some sort of a slope, this axis will be in a different plane, right? So that's why they are called slope axis. But if we are walking on a flat plane, like a ground or something else, then we can think of these 2 axes as a forward and right axis. Okay, so we have a horizontal velocity here. We have a slope axis. How do we actually get the values? Let's I would say that this might be a good opportunity to improve first-person controller by introducing these two parameters like float, let's call it local horizontal velocity, which basically will return vector 2. Please tell me if you have enough time to play by introducing the minimap in the upper right corner to track the movement of the character, if of course this was included in the course plan. This was not actually included, but thanks for asking. I think we might be cover some approaches how to do this later in the next live stream sessions. So what I need to do here is to it will be very good if the developers will update the existing first-person controller and add this helper. Basically, we need to understand how far we are moving relative to the player. So we don't need to know like the absolute velocity. We need to know the basically the movement vector, right? So how can we do this? We are going to use dot product. Object 2, and here we are going to use dot product slope axis forward and horizontal velocity. Let me do it like so. Or maybe movement. That would be better. Okay. No. Must declare a body. Okay, let's just get rid of it. Okay. Is C# code works on Linux? Yeah, of course. The C# code works on every supported platform. Okay, so we have a local movement vector here. No. Still no. Okay. I don't want to put this in the in this component code because it does not belongs to this. This component should be only responsible for the animation blending, and that's it. Okay, let's get our movement vector. Movement, and let's actually change this to this. So back to okay. So right now this is from -1 to 1, and Y is also from -1 to 1. And that means that if we think that forward should be mapped to 0 to 1, that means that we are moving forward. X is in 0 to 1. And backward, if we let's do it like so. X is in -1 to 0. Here, right, Y is 0 to 1, and left, Y is from -1 to 0. Okay. So this would be our weights, but we need to reverse these two because we can't use negative weights. Okay, let's try it. This would be idle weight, and this would be. Is it necessary to use Visual Studio Code, or you can use Visual Studio 2019? Yeah, of course you can use Visual Studio. You don't have to use Visual Code. For example, you can actually go to the My Project section and click this Opening Code IDE, and then you will have your Visual Studio project in which you can work with the all the code base, and it will also include all the components here. So these two. Basically, you can work with Visual Studio as well. But I personally prefer to work in Visual Studio Code. Okay, so we need to to calculate all the weights from this. Knowing this, we can easily calculate all the weights. Okay, walk forward. Let's call it walk mix weight. Walk forward is movement vector x, but we need to be sure that it won't go negative. So we can do the maximum of movement vector x, and we can do the same walk backward, but instead we're going to use negative x. Here walk right, we're going to use y value, and here we are going to use minus y. Okay, let's also port that to for loop, non-layers. Okay, now we need to set weights for our animations, for our layers, all 5 layers. Okay, that's pretty much straightforward. First of all, we need to set the weights for the specific animation, and then we still need to blend it with idle. That's why we still need to multiply by this initial weight. All right. This will make our animation switch between different walk animations, but as we did with the previous example, we do that instantaneously, and you will notice it will look very bad, even if we have a smooth transition with the idle animation. Let's have a look. Okay. See, the transition is not that smooth as I wanted. So let's do it a little bit. Let's do a little bit better. Okay. We will do the same approach as we did with this idle mix. So we will do an exponential fall off to the target values. So we need to store the current values, like current walk forward. backward, walk right, walk left. Okay. Thanks for the tutorial. I hope to see RTS camera next time. We'll see. Okay. So here, this would be our target weights, right? This is what we wanna hit. And here we will use current. And here we are going to do the same approach. Again, we can at this stage we can put this to some sort of array and make this look prettier, but that's not the goal of this tutorial. My goal is to show you how to, you know, how to calculate this in a very explicit manner, so you can understand what's the important steps to do. What are the important steps to do? Okay, and right. So what we did here, as I mentioned, we stored the current weight, and we know the target weight, and we can do some sort of a smooth function which can go to which tries to reach this target weight. And here it's actually an error. I should use current value here and current value here. And here let's put another damping. Let's name this as idle walk mix damping. And here we'll just name it as walk damping. Okay. UNIGINE in action suite, nice to watch. Alright, so now we have a smooth animations. Yeah, that looks much better than, like, please do a smooth transition between animations, because it will look very natural. Okay. Yeah, see the shadow and get scared. Yeah. Alright, so the last thing about this setup is to do the actual shooting animations. How can we do this? Like, we already have some sort of complex setup here, and we need to do even more. Let me do a simple diagram of what we already did here, and then we can do. Imagine that this is my blend tree tool, right? So what I actually did. So I actually have like 4 animations, like 4 walk animations. They are connected to this blending thing. Then I have my idle animation. This is walk forward, walk backward, walk right, walk left. And then I have an idle. And here I have a mix. So this is basically the blend tree that we implemented right now in the code. Please tell me, will we turn off the shadows from the hands through the mask? We will turn them off, yes. And there are two more parameters here. The first one is the movement vector, which is used here. And another thing is like is moving. These are somewhat of, you can think of this as a variables. Let's make this greenish, because these are specific connections as a variables. Okay, so this is what we implemented right now, and we need to add another thing. We need to add shooting mechanic. So basically what we're gonna do is we're gonna add another mix node here. So we're gonna have shoot. This would be our animation, and we will have another mix here. That's what we are gonna code. And actually there is a missing part here. We need to feed the mix value here. And let's call it how should we call it? Let's call it shoot weight. So as you can see, if we have our, maybe use Miro or some other tools to clean diagram creation, maybe, but it doesn't matter at this point. What I want to explain is that we need to introduce another layer, and we need to introduce another mix here. And we can control this mix by this variable. And the way we're going to control it is, if we press fire, then this will instantaneously go to 1. Like we will instantly transition to the shoot animation. And then if we didn't hit any mouse button, then this will slowly go down, and thus giving us back our idle walk mix. So that's what we are gonna do. Basically, this is blend tree, the same blend tree that I just drew here. Okay, so we have a shoot animation. Let's add more layers, like 6. And let's have another parameter like private float current shoot mix. 0 means idle walk mix, 1 means shoot animation. Okay, so how can we understand that we need to shoot? Like in ideal world, you have to create like the another component in which you will handle input, but for the sake of the this basic tutorial, we are going to do it here. But we will do it in at least we will let's go it so. We will do it like so. So if we wanna shoot, so we will set the shoot mix to 1. That's the first thing that we need to do. The second thing is that we need to set frame for our shoot layer to 0. And this is important because we need to start our animation from the ground up. And another thing is that here we are setting frame for every animation, including shooting animation, and we need to count to make another counter for it. Let's current shoot frame, and here walk idle frame. Current shoot frame. Let's get rid of this. 1, 2, 3, 4, 5. Okay. And we will have another parameter for the animation speed. We still keep it as a 30 frames per second, but if we need to fine-tune it, then we can do so. Okay, and let's actually reset a frame here, like so. Okay, so now we have a current shoot mix and current shoot frame. So let's first set the layer weight. This is pretty much simple because we only need to set current shoot mix, and then we need to do another thing, shoot walk idle mix, and we will basically reverse that. And then we will multiply it, like so. Okay, so now this idle walk animation depend on either we're shooting or not. Alright, so let's continue, and one more thing that we need to do is to slowly or not slowly decrease this value. And the cool thing that the target value for this mix is always 0. Because we need this to go down. And we will introduce another variable. And for this we will use different value because we need it to go much faster. Or actually no, we need it to go a little much slower than this because we need to be able to see the shooting animation as long as possible. So that's how we deal with the... Let's actually split this into smoothly update current weight values. Here update animation frames. Let's go it like so. Here is calculate target values for weights, for layer weights. Here apply current layer weight. Okay. Maybe better firstly to show this right simple solution without animation blending to see the difference. I already did that. We actually gradually transitioned from the simplest thing to the complex stuff. Or you mean the shooting thing? Yeah, of course. This actually what will not be so easy to do, because here we set the we still need to keep some sort of a state which will tell us that are we shooting or not. And this approach, by using this approach, we don't need to store this state here. All right, let's have a look. And we still need to do some sort of this is shooting, and then if it's shooting, then shoot, not shader, shoot. And this is the part where usually we split input from the animation, but again, for the sake of the simplicity and for the sake of tutorial, I'm gonna put this code here. Like we're going to use input is mouse button down, and here input mouse button left. Let's have a look. Looks like we did something wrong. And let's see what we did wrong. Whoa, that looks dope. Let's also organize this properly, like so, so it will be more clear. If I get using bullets for gun, we'll get to that. We'll get to that. It's the easiest part of this live stream session. Like the animation blending and the first person setup is the longest one. Once we finish with this, the other thing will be very easy to do. Okay, let's see what we did wrong here. Thanks for your all great work. Need to quit now. Hope to watch the record again. Good luck. Good luck. Have a nice day. Okay, so current shoot mix, shoot dumping. So this should be set to 0. This is okay. Set frame is okay. Num layers. Num layers is also correct. Layer is enabled. The weight is, yes, the weight is correct as well. Shoot dumping. This is 1. What did we miss here? Let's disable this and see if we will be able to will be able to see the shooting animation at all. Looks like it uses different animation. Oh, okay, yeah. That's why. Okay, copy paste. Right. Okay. Yeah, now we're talking. Okay, so now we have a shooting animation, and we need to gradually give back control to the walk idle mix. Okay, so now we have our walk idle mix. Now we have our shooting mechanics. Okay. Yeah, nice. Yeah. Okay, now looks like bullets indeed in the gun. Yeah. Yeah, now it feels much better. Okay. Okay. And there is a bug in this code because this animation, like the shoot frame, will go indefinitely, and that is the bug because we only need it to be we need it to stop at the end. Otherwise, you may notice this artifact. Can I make this game on 4 GB RAM laptop? I guess so. See that small glitches? Like, it's because the animation is looped. So we need to get rid of that. Once we get rid of that, basically we finished all basic setup. That would be it for the first person setup, and then we'll have time to add cool things such as the actual shooting. All right. What do I need to do? I need to get the shoot animation interval or frames. And we are gonna get this very easy. Now shoot animation frames equals mesh skin, get num animation frames, and then we will use the same index, but is this work will be published as a template? Not as a template, but it will be published on a GitLab as a public repository. So in this particular setup, this will work, but in order to be able to correctly get the animation, for example, you might have like different setup, like many layers with different animations, which can be duplicated here, and therefore this index might give you different results because it's not one-to-one match. So basically it's better to get the animation ID first from mesh skins, get layer, or get animation ID, not the ID, get animation from layer 5, and then we can go like so. Show results there. 1 second and I will show it to you. And here we need to clamp the shoot frame. We'll go like so. Math library. We'll take what's less. Either this or that. Shoot frame. Okay, so now the bug is gone. So we have a smooth transition between animations, we have shooting mechanics. Now let's do the actual shooting. I have Intel Core i3 CPU and 4 gigs RAM. Can I run? You can try. The project will be publicly available, so you can try, go and play with it. Alright, so we have a smooth animations, which is nice. Now, how can we do the shooting? let's reorganize code a bit, and I will put it as a to-do, move to input component, like is shooting. And I will simply do it like so. Is this some sort of school shooting game? No, definitely not. It is just a starter content. It doesn't look like a school. Okay, good. Now, let's have a look how can we actually do the shooting. You can do it two ways. The first way is to go to the pistol and create a bullet and create a specific node dummy here and spawn bullet from this dummy node, and then let the bullet go through, basically go somewhere. And that might work, but we want to be able to shoot exactly at where we are pointing, because this is very important. Otherwise you won't be able to aim properly. And if you just go shoot bullets from this point, you might not be able to hit any target because of the perspective. Instead, we will do we will take the camera, and because our camera minus z axis is already looking, it will be pointing into the middle of the screen, right? So we will just do a simple raycast from the camera to the middle of the screen, and then get the intersection, and then see if we hit something. Did you learn C# for C# or C# for game programming? I'll learn C++. Okay. So the next thing is to... This is hand animation controller. How can we do this? What? I think let's create another component. Create a component, and then we will shoot controller or weapon. Let's call it like so, weapon controller. Jump animation. I don't have any jump animations for the hands, so there won't be any, sorry. But basically, if we do it in the code, we need to first draw some sort of a blend tree here, and then we need to understand what values do we need to bring here, and then write this in the code. It looks messy, especially if you want to just tinker with the prototype, but it works, and it shows you how the underlying tools are working. Okay. Let's go to the weapon controller, and in this weapon controller we will be needing our camera, player dummy camera, like shooting camera. Okay. And we will probably place this weapon controller to, let's say, player, because it already has one component, let's put it here. Weapon controller. Okay. So for the shooting camera, we will use player dummy. And here we are going to use very simple code. We will store 2 points. And then we'll ask our shooting camera to get screen position. Not get screen. Get direction from screen, yes, this one. It's C++, I think I shall just watch from now on. This is C#, it's not C++. And here we are going to get our points, P0 and P1. Here we can also provide additional arguments, which will basically mean define the point on the screen which we are going to project to the real world from the camera. But default settings are good for us because they are basically means that we are going to shooting from the middle of the screen. So basically that's it. We have our 2 points, and then we need to do the intersection test. For that purpose, we have a world get intersection. And here we have a lot of options. But we would like to use the function which will take 2 points. So we provide 2 points, and then we will have like another parameters like mask and many other things. So let's put mask here, and then we have world intersection normal here. So let's call it hit info, and here we'll just instantiate world intersection normal hit info, and we need to put this mask, and let's put it as a parameter. Parameter mask. Let's have a look at what. Yeah, type intersection. Type equals parameter mask. Mask type. Mask type equals type intersection. Here we go. Okay. And another thing is we might hit an object. So this function will cast a ray starting from point 0 and 2.1, and it will try to check the intersections with every surfaces that have this intersection masks. And if we have an intersection, it will return us an object. Let's call it hit object. And it will also return us a specific hit info like the intersection point and intersection normal. That's actually what we need. Let's first visualize this. Visualizer, render, vector. Then we can use hit info, point. Like if we have a hit, then we can visualize this. The end of the vector would be hit point plus the normal. Color let's use red. Arrow size, let's keep it 2.5. Screen space false. And here we have an interesting parameter. It's called duration. It basically means how long this visualization will stay. It will help us to debug this thing properly. So we will set 2 seconds. So that's it. We have a shooting mechanic. C# scripting on Unigine looks difficult. Looks the same to me as in any other engine, because like any other engine have the intersection check, the visualization helpers and objects. Make destroyable wall. We actually did that on the last live stream session. Okay, we have weapon controller, we have intersection mask. Let's play and see if we can hit something. So as you may notice, we didn't saw anything, but if we go to the console and type show visualizer, we can see that actually we are hitting objects, which is nice. And of course, we don't need to call this in update. We need to do this in our own method. We'll call it shoot. And yeah, for now we need to make another component. Let's actually make an input component. Can we change visualization pointer to point instead of vector? Yeah, of course. I prefer vector because it will also show us the normal. That might be important to do some debugging. For example, if you want to do some ricochet, or like I don't know, if you want to make bullets going through the walls, this might be very handful information. Okay, let's create the third component. Let's call it how should we call it? Input. Oh, let's call it directly shoot input. And we will do very simple stuff. We'll just move this thing here to this component, like so. We actually don't need any of these methods. We don't need init, we don't need update. We only need to move it here because right now other components can use this shoot input. For example, we can use it like so. Shoot input is shooting, then shoot. And we can do the same to the weapon controller here. Right, private. We can write our own simple update. Something like that. And here we need to shoot input. And we need to do the same for the first person controller. The only big thing I'm actually missing in Unigine is an UI system as you know it from Unity. Yeah, this tutorial will also cover shooting AI. No, this will be covered in the next live stream. Okay, so I have an errors. What's wrong? The shoot input does not exist. Okay. So we need to place this component somewhere. Let's put it to close to our player here. Let's call it should input. And here, for example, we can in shoot input we can define which button will act as a shoot. I think in my life someone answered me. Yeah, I know that feel. Okay, let's move this component here. Should input. Let's also move it here as well. Yeah. All right. So this should look the same, but it should react to our input. And if we gonna show visualizer, then we see that we're actually shooting, and we have normals, but we still don't have any special effects. But we have all the information. We have what object do we hit. We have information about the position and normal. So yeah, that's basically what we need. Reload time. No, not this time. We will add it maybe later. And I don't have a reload animation, unfortunately, so not this time. All right, so let's make it look a little bit cooler, shall we? Instead of doing a simple visualization, we can here we can notify different subsystems. Like if we have some sort of hit as a fixed subsystem or a component, VFX actually, we can create a hit effect, and we can just put the point and the normal and hit object as well. That way the system can decide which effect or which logic apply according to this information. These two usually needs to properly place. Can recasting make a delay to target to represent as a real bullet? We can do so. For example, if we know that this is a raycast, and if we know that this thing was hit by a bullet, then you can do some sort of delay, but it's usually done in another way. It's usually done via real bullet that is going through the muzzle of the gun, and then it goes a straight line, and then basically you will have a delay. Okay, let's actually do that subsystem, because it's not there yet, but I would like it to be here. Let's call it hit VFX controller. Are you kidding me? How do you get an intersection point using an orthographic projection? I can't seem to get it working. It's basically the same way you get the intersection point using perspective projection. There is no difference in it. I mean, the first one is a frustum, the second one is a cube, but the faces and the points on the faces, especially if we are talking about the middle point, the math will be the same, almost the same. So it's not a problem. Okay. Let's call it hit VFX. Not the VFX. On hit. Okay, and all we need to do is to add this VFX controller. Actually, let's call it even better. Let's call it VFX controller, because we not only want it to represent the VFX, we also want it to represent the muzzle flash as well. So VFX on hit. Okay, cool. Now we are going to add a public method called onHit. It will contain a point. It will also receive a normal, and it will receive an object. Let's call it in a consistent way. Okay, we don't need this for now. And what we need actually here is we need some sort of a prefab for the hit. Let's do it like so. String hit prefab. Thank you so much. I'll see if I can get it working later. I really appreciate these live streams. They're helpful and insightful. Much appreciated. Thank you for coming, and yeah, have a nice day. Okay, here we need to specify which type do we want. We want to use a filter for specific files. Okay, so this will be a hit prefab, and here we are going to use load node. Name will be hit prefab, and if string is null or empty, hit prefab, then we will do nothing. Then and here we need to position it properly. So first of all, let's place it like world position to the hit point. And here we also need to set a world direction here. So we need to set it to look to the normal. But the trickiest part here is that it's up to you to decide which axis are you gonna use, like which axis in your workflow will be counted as a forward direction, and we will set this node direction to the normal, and we think that the node forward axis should be matched to normal. Should be matched to the normal, should look across the normal. Okay. Default parameters is -0, which is not what we typically want to use. The typical parameter for UNIGINE is defined as -y as a forward, and that's what we're gonna use. Okay, so this is our component. Okay, so it compiles, and then let's add another component, the FX controller. And now we need to add a hit prefab, and for some reason I can't import this properly. Let me try it one more time. This should work. Palette hit. yeah, okay. So this works. Even so, there is some sort of a missing files, but it looks decent. And another thing is, I guess we need to import another component. Let's import it here. It is called destroy. Will it work? Looks like, yeah. Okay, I need to kill it. Okay, let's run it again. Okay. So this is my live stream session. World. This is our hands, and let's see if it imported. No, it doesn't. Okay, let's just create another component and call it lifetime, or yeah, let's call it lifetime. Okay, and then I will just, for the sake of saving time, I will just copy this source code like so. Oof. Basically what it does is it allows you to define a single time interval for the node in which it will live, and after that it will die. It will be deleted. So that's what we are going to use for the VFX. It works. Will this series all parts cover of shooting AI? Yeah. The shooting AI will be in the next live stream session. Okay, so we have a lifetime, and let's modify our bullet hit prefab here. So it has a component which is called destroy, and we'll change it to lifetime. Let's put like 5 seconds lifetime. Okay, so right now we don't need this, and all we need to do is, first of all, let's make sure that we have all links here, and we don't have a VFX controller here. Let's also put it here, VFX controller. Hit prefab will be bullet hit, and then we're going to use VFX controller here. All right, so let's have a look at the how it actually works. All right. Yep. See if we did the right thing. Okay, looks like there are some missing textures still. And another thing is that this looks like it's reversed. So it looks like the forward axis for this particular node is forward Y. Let's change this and run it one more time. Make a sound effects. We can go and download from a free sound. Yeah. So now let's see, we have some sort of a VFX going on. Yeah, I'm sorry that some textures are missing for some reason. I'll figure that out, I guess, after the stream, and I will upload the fixed version to the repository. Or maybe we'll have time to find out the problem. We'll see. All right, so this looks nice, I guess. This, at least to me, this feels very nice to be able to shoot. And there's one thing missing, is the crosshair here. Let's add it. And for that, we'll make another component. We will call it HUD. And for this component, all we need to do is to, first of all, we need to, so the next step is to add network and let's play. Yeah, basically Battle Royale, yeah, is done. Here we need to set the crosshair image. I'm very worried about one question. Please tell me multiplayer. How to implement 2 players online? This engine has such an opportunity. Is there any third-party development that could be implemented together with the engine? Of course, there are a lot of third-party libraries that can be used within the engine, because it has C++ API, so feel free to integrate any networking library you want. There are no networking library out of the box, with the exception for the standard circuits. Okay, so there are 2 ways we can build a UI in UNIGINE. First way is to, basically they are like, not the 2 ways, you have only one way, but you have 2 places. The first place is to use the screen GUI, like the one you see here, like where the frame counter located, and you can put your crosshair here. You can do it so like so. You can get an instance of a screen GUI, like so, and then you can add widgets, like widget sprite, for example. Let's actually keep this as a state. And here we have sprite, new widget sprite, and here we will need to add screen GUI and an image. Then screen GUI. Then we need to add this widget as a child here, and we can also define some sort of flags. Hello, I'm a beginner. What are you doing? We are doing a live stream where I'm showing how to create a first-person game using UNIGINE. And here we will use flags like so: GUI, align, center, and GUI, align, overlap. That means that this sprite will stay at the screen center, and this means that it will be on top of any other possible widgets. Okay. So that basically it for the crosshair, and let's see, let's actually test this. I would say that it's better to create a new dummy here and call it a HUD, and then add a HUD component here. And for the crosshair image, I will use the texture I made for the live stream session. Let me find out where it's located. Yeah, found it. So this will be our crosshair image. It's very simple. Okay. I need to add parameter, set it as a parameter file without any filters, so I will be able to set a texture. Okay, good. Now let's go and play. All right, so we have a crosshair. Looks too big to my taste. Let's put the parameter that will allow us to control its size. Let's put it to 16, I guess. Oh, whoa, whoa, whoa. Let's fix this. Okay. Yeah, much better. So now we have a crosshair and we shoot directly at it, which is important. Yeah, I think the last thing that's missing is the muzzle flash effect. Here's another version. After building game, it weighs a lot. You mean the overall build size? It depends on your content, I guess. And yeah, UNIGINE team definitely improved how the building process worked, but I don't know about your specific project, so I can tell you the details. Okay. So we have a bullet holes. We have sparks. Let's also add the bullet spawn effect. Let's see if it will import properly. Yeah. No. For some reason, this is missing some important textures. Okay, let's do this thing. Let's go to the demos and download third-person platformer. While it will be downloading, I will show you how to do a muzzle flash effect. I ask, will we get any kind of a new UI system 2.14 a little later? I guess, yeah, UNIGINE dev team will answer that. Okay, so first of all, for the muzzle flash effect, we need to add a specific node dummy to our pistol here. So let's do just that. Node dummy. Okay, let's with like so. And let's call it muzzle. Okay. So the muzzle flash is very simple to do. We just need to go to our VFX controller, add another prefab, which we'll call as a muzzle flash, and then void on shoot. We'll need to do this thing. We go to the weapon controller, and here we will need to yeah, let's do it like so. VFX on shoot. We don't need to store anything specific yet. Yeah, this will definitely work for a single weapon. If we will need to what's the problem? Probably didn't save this. Yes. Public asset link node and dot load. Asset link node hit prefab. It's easier to understand, I guess. Yeah, probably. Okay, so what we need to do here is here goes the tricky part, because I would say that this should take the transformation, and then it should create just a muzzle flash effect, and that's it. And then muzzle flash prefab world transform. That's it. We don't need to store links to muzzle flash connections in VFX. We will be storing it here in weapon controller. And later, if we will have a lot of weapons, we can do another component and store a list of weapons here. But for now, we'll just store the weapon muzzle here. And if we have one, then we'll do this. Okay, so let's go to the first person controller. Let's go to the pistol and see the muzzle, and then let's add it here to the weapon muzzle. Okay. And another thing that we're gonna do is we're gonna modify this prefab like bullet spawn. We will replace this lifetime to maybe like, yeah, 1 second should be enough. Okay, let's delete this. Without improvement UI system, it's a little hard to implement any game menus. Yeah, that's why you can integrate like third-party solutions such as Noesis GUI or any other. Yeah, I guess a lot of people would be very proud to see some update in this area. Yeah, UI is, especially game UI, is always hard to implement properly. All right, let's see if we have a muzzle flash. Oh no, we won't have it. So we need to add the prefab first. Here. We will call it bullet spawn. Okay, thank you. I just wanted to say that you don't have to wait until it will be done. Yeah, we need to fix that missing textures. That'd be awesome. Maybe some web-based C++ UI like Ultralight or Noesis or like any other web-based. There are a lot of frameworks. Some of them are tailored for the game development. Some of them are more general purpose. All right, so basically that's about it for today's live stream session. Let's fix these textures. Let's think that we implemented all the master, don't go away. That we implemented all the required features for today. Like we now know how to blend animations, we know how to do raycasting and simple shooting mechanics, we know how to integrate some simple visual effects, and later on when you will scale your project, for example, you don't need to spawn nodes instantaneously. Instead, you need to use caches. But as we already split this into like a small components, you can just replace the implementation here, but you don't need to touch the interface and how they interact with each other. So instead of just loading node, you can use like internal caches or something like that, just to maintain your performance, right? But again, for the sake of tutorial, we are going to just use this. And I need to fix these missing textures. They are kind of annoying. All right, so yeah, muzzle smoke requested. Let's see what's missing. Let's start with the heat node. I guess it's some sort of a smoke that's missing. Oh, I guess these two stuff. Let's call it like VFX common, and let's add these two materials. Yeah, this smoke, I guess. And if not, then we will add this ourselves. Okay, feel free to ask any questions, because like there is an end of the stream and we need to wrap this up. And yeah, while I will be fixing the missing textures, feel free to ask any questions. I think we will do like 15 or to 20 minutes of asking your questions, and then we will end this live stream session. What if I just replace this? And this is probably missing textures as well. No, it's fine. Would a third-person view just be a zoom out of the camera? It depends. It definitely, you will need to do a little bit more complex animation blending, because like especially if you want your character to walk on a terrain which is usually not flat, and then you will have to do some sort of a locomotion system, and you have to blend animations. I will fully switch to Unigine from Unreal if you cover AI. We will do that in the next live stream session. What else do I miss? Actually, these materials are there. Yeah. Thanks. Also the Discord invite. Good stream. Yeah, thank you, thank you. Okay, so this is missing. Flash hit. Flash hit. So we have a flash hit material, but we seems to miss a texture. Maybe let's move these two textures as well, and maybe let's test this texture. Make a full game, have it shoot a specific target and end game. Yeah, that's what we are gonna do. Mission texture. And it should be the same, probably. Oh, that looks odd. Very odd. No, that's not the right texture. Maybe one other thing, not for this chapter, but for version 2.13 in general, if I may. Yeah, go on. 4K support for the editor. Oh yeah, that'd be nice. I have like a 2K monitor here, like 1440p here, but it runs in Full HD right now for the sake of the live stream. But yeah, I know what you feel. Hello, will you add this example as a template, as a third-person template of the robot? I'm not sure if it will be a template, but it will definitely be in the public repository. It would have been better if you had used full character as a player. Yeah, but the only content I have is these hands. Maybe later we can switch fully to. Actually, let's do just this. I'll copy this as a project, and then I will just steal the content. Was there a topic about bullets piercing walls? No, not yet. Muzzle flash will be visible as a paper sheet for other network player, or a little bit better as an array of half transparent papers with different orientation. Is there a case of using volume 3D shapes for that, with changing shapes and scaling, or other approach for good quality? I think it's mostly artfully related question. The approach to this could be quite different depending on your art style. But I think that at least this effect, it tries to implement some sort of a volumetric effects with the particles and stuff. It will also be for those who want to create third person. If you want to create a third person, you can download a third person project, which I'm actually doing right now. And what I want is to steal its visual effects, like particle effects, and reuse in here. That's basically the content from the third person platformer. So let's see, and let's see how we can steal it. Okay, so here we have a third-person platform, but it's not the topic of this live stream. What I want to do is to quickly steal. Yeah, so we have a bullet hit, bullet spawn, bullet materials, textures, muzzle flash. Nice. Textures. Okay, bullet hole. So we already have that. let's just grab these two, like bullet spawn and bullet hit. Okay, so let's try and show assets used. Gun smoke, lens flares default, gun smoke. So these two textures, these two weird ones, and I guess I have them. Let's see. I will spend like 5 more minutes on this, and then we will wrap this through. Okay. Okay, I will see it anyway. Thank you. Yeah, you're welcome. So we have this texture, and we don't have another one. Let's okay. I guess we can just copy all this and then particles. Yeah, right, these things. Yeah. Wait, are you in this part make a hunt for the side of a player and for side player stats? I already did that. I only did a hunt for the site because we don't have player stats yet, so I decided not to do it on the first live stream. You can see we created a dummy object here. We named it HUD, and we created another component which is called HUD, and inside we have link to the image, we have a widget sprite, and we put this sprite on the screen GUI. So that's how we basically managed to implement screen HUD. I'm greatly thankful to Unigine community. Thank you. All right, let's do this quick thing and see if it will work or not. So for that, I will create like another like stolen from third person demo. And then we will import like so, bullet and particles, and see if we still can use hit. Yeah. See? No problems. Done. Let's actually delete these two, and let's use these two. Yeah. That's great. Okay. So let's first fix the bullet hit prefab. Instead of destroy, we will use our lifetime. And for the bullet hit, we'll make it 5 seconds. And for the bullet spawn, we will keep it as 1 second. Okay, so then we need to go to here and add these missing prefabs. So bullet hit here and bullet spawn as a muzzle flash effect. All right. Still missing, but at least we get muzzle flash working, and it's too bright. So we didn't import some sort of a sparks. Okay. Alright, so that's how you do first-person shooter. Like that's how you do the basic stuff from the scratch. Like if you wake up in a desert, that's how you do it. ADS maybe add in aim downside. What's add in aim? You mean like a recoil? Can you give an idea what this series will cover, please? So in the second live stream, we will cover the AI, how to use navigation, how to work with navigation meshes, what the current workflow is, what the future workflow could be. We will talk about the finite state machines and simple AI. We will also do player stats like health and damage. ADS like in Cyberpunk 2. Or you mean iron sights, I guess. Yeah. If we will have animations, then it's definitely doable. We will see. Because like for now we don't have a jumping animation, we don't have landing animation. We still it's better to as a small touch to like move the weapon to the side where your mouse acceleration is, stuff like that, just to make it even more lifelike. And then of course we need to do the iron sights, we need to do the reloading. If we'll have all the animation, then yeah, that should definitely possible. Alright, so I'm gonna switch to my talking head and we'll spend like 5 more minutes talking with each other and I will be answering your question. Alright, so will it have dynamic crosshair in the HUD? Yeah, that's one small touch I want to cover in the polishing livestream session when we will do fine-tuning and when we will do small tweaks. All right, any other questions? Adopt me. What would be the next live stream topic? The next live stream topic will be about AI. How to integrate AI in first-person shooter demo. OpenXR support? I don't think so. Or you mean the engine feature? I think the engine doesn't support any AR specific stuff right now, but you can integrate it if you want. So if I combine this tutorial and the third person one, I can make a shooter game with destructible environment, right? Right. Will Unigine have something like Unreal blueprints? I guess dev team is working hard on the node-based editor for like not only for the material and shaders, but also for game logic. But I'm not sure. But that's what I heard from them. So can we ask you things directly in Discord? Yeah, feel free to ask me. I'm not sure if I will answer in time, but I will do my best. Node-based scripting is coming in 2028. 21, sorry. Why was I saying 28? 21. All right, any more questions? Like, let's do the last 2 questions and then we will end the stream. A technical question: are you guys thinking of integrating Lua? There is no point in that. And B, what? Not based, yeah, not based scripting is great to see in UNIGINE, right? How many episodes? I think 3. In the second, we will cover AI and player stats and do a simple game loop. And in the third one, we will be polishing all this stuff. But this is the subject of change, so we still need to think about it. Yeah, you can can't wait for the next month. A UI, not an AI. No, it's AI, artificial intelligence. There is not much of UI in this demo, so there's nothing to cover. Alright then, I guess that will be the end of this live stream session. So thank you all for coming. I guess you had a great time and you learned something new today. In the next live stream session, we will mostly talk about artificial intelligence and how to do the enemies, how to do the shooting damage stuff like that. So thank you all for coming, and I will see you in the next stream. All right, bye bye.